Hello everyone, I'm Jay Joshi and welcome to the 26th episode of Learning Java. Today, we'll be learning about the basics of object-oriented programming. So, what is this object-oriented programming? So, to know this, you might know that when you start learning Java, you're taught that Java is an object-oriented programming language. And there are other object-oriented programming languages as well, like C, C++, etc. So, what is this whole concept of object-oriented programming? So for that, we first need to know what objects are. So an object is basically an instance of a class. So let me explain what this means. You might remember what a function is. So to declare a function, we first have the access specifier, whether it's static or non-static, the return type, and the name of the function. So let's say I have a class fun over here, and I make a function public static void, and then the name of the function can be something like hello. So let's have a function like this, and what this function does is it prints system dot out dot print ln, and it prints hello, a very simple basic function, print ln. Now since it's a static function, we call this function by just calling the name of the function in the main method. So we can just do this hello with brackets. There are no parameters, so it's just open and close brackets. So this is how we call the function, by just using the name of the function. And let's say we have a different class, then we can use the class name. We get into that a bit later. So for now, if it's a static function or a method, we just call it using the name of the function. But let's say we remove the static. I told you that static is a category, so a function can either be static or non-static, and variables can also be static or non-static. So let's say I remove this static over here. Then if I call this function, it doesn't work. So it gives the error non-static method cannot be referenced from a static context. Now what does this mean? This is a non-static method. Why? Because there's no static over here. And we cannot call a non-static method from a static main. So that's what it means. Non-static method hello, since this non-static cannot be referenced, cannot be called from a static context. And since this main is static, we cannot call this. Now you might just say, let's just remove the static from here. But no, we are not supposed to do that for now, because although you can do it, it's better to always have static in the main part, and I'll explain in a later video why that's important. But for now, we leave the static in the main. So how do we call this function? So to call a non-static function, we need something called an object. So in a static method, we call it using the name of the method. But if it's a non-static method, we call it by using an object. So let's see how we make an object. So to make an object, we first put the class name. So in this case, the class name is fun. So fun, then you have a space, and then you put the name of the object. So an object can have any name, it should just follow the identifier rules. So in this case, let's say our object name is obj1. Then you put an is equal to, so class name of the object, so fun obj1 is equal to new. This allocates memory, this keyword allocates memory for the object. Fun obj1 is equal to new, and then you put fun again, which is the name of the class, and then open and close brackets. This is how you create a function. So with this line, what I've done is I have created an object fun. Not fun, obj1. So I've created an object called obj1 with this line. You have to learn this line. It's very easy, not that complicated. The class name, the name of the object is equal to new, which allocates memory, and then the class name again, and then open and close brackets. Now this open and close brackets is again space for parameters, and we are leaving this now because there are no parameters. I'll be explaining what this is based on constructors in a while. So this is how I've created an object. Now when I want to call this function now, I can call it using something like this. This is how I will call a non-static method using an object. So what I do first in main is I create an object. And now this object can be created in a method also, it doesn't really matter. So I create an object over here, and then I call this function hello using that particular object. So obj1 dot hello. So whatever the name of the function is, and over here are the parameters. In this case, there are no parameters. So this way the function gets called. So first we create a function and then an object, and then we call the function with that object. So this is basically an essence of object-oriented programming. An object is nothing but an instance of a class. So if I compile this code, you can see that it just calls the function hello, which works. So now you just might say that why would I use this object-oriented programming? Can't I just like make a starting method and just call this? Well, it's much better to use non-static methods, which you'll see when you're writing your own codes. Later on, when you're writing massive codes, it makes the codes much more compact, easily readable, and it's much easier because with objects, which you'll see in a bit. So this is the basic essence of an object. Now, one more thing which is very important in object-oriented programming is we can have variables in the class. Now, let me explain. So you know how we declare variables, right? Let's say int a double d. I just normally just initialize and declare variables over here. This is basically the initialization of variables. I can do this in main. I can even do this in a function. It's fine. But can I initialize variables in the class? So you might know that, let's say if I initialize a variable over here, let's say int a is equal to 10, I cannot use the variable a over here. If I do something like a is equal to a into a, this will not work because this a variable hasn't been created. It's only been created in this main. I cannot use it over here. So what if I want a variable which is common for every single method or anything? For that, I can make a variable in the class, not in any function or the main. I can make a variable in the class, which is called which is called a class variable or an instance variable. So if I initialize a variable over here, int a. Now this variable I can use in this function. So I can do something like a is equal to a into a. For now, so you need to give a value, which you cannot do over here. You can only initialize variables in the class. So over here, you can only initialize variables. You don't like declare them. You don't give them any value. You need to initialize them. So how do we give this variable a value? Which I'll be showing in a moment with the help of constructors. So you can see that for this variable, I only said int a. Now, can I use this variable over here? So as you can see, this variable works perfectly fine over here, but can I use this over here? Let's see. So if I do something like a is equal to a into a, you see this doesn't work. Why does this not work? Because this is a static method. It's not a method, it's static. So this entire main is static, but this variable is non-static. And so this is why we cannot use a non-static variable in the static method. So like how we cannot invoke a non-static method normally in a static method, in the same way we cannot use a non-static variable in a static method or something. Let's say if I make this also static, then this will also not work because this is static and this is a non-static variable. Now, how do I make this variable static? Just in case if I want to use it, I can do something like static over here. So if I put static below it, this variable becomes static. So now it's static int a. So this variable integer a is now a static. And now this static variable can be used in this and this because both of these are static. And if I remove this over here, we can still use a because static variables can be used in non-static, but non-static cannot be used in static. So let me just repeat that. We can use static variables in static and non-static methods, but we cannot use non-static variables in static methods. We can only use them in non-static methods. Now let me just give you another example. So as I said, the static variables can only be used in static variables can be used in both static and non-static methods, but non-static variables cannot be used in methods. But this is different for methods. So let's say I have a non-static method over here, hi. So this is a non-static method. Can this be invoked in a static method? Let's see. So if I do something like this doesn't work. So we cannot invoke a non-static method in a static method, but the vice versa is possible. So hello is a static method and I can invoke hello in a static method, in a non-static method. So static methods can be called in both static and non-static methods, but non-static methods can only be called in non-static methods. So this is an important thing to know, what this static and non-static is. So it's basically a division of category. So now you know that you can initialize variables in the class. I can have multiple variables over here, let's say double D, anything. I can have strings, arrays, anything. Now we know that. Now let's look at what this bracket is all about. Where are the parameters in this? What does this basically do? So now we are going to learn about something called a constructor. So what is a constructor first of all? So a constructor is kind of like a function, and at the same time it's not like a function. So let me explain what a constructor is. So as you know that this is a function. So first we have the access specifier, then we have the static, non-static, then we have return type, and then we have the name of the function. And this can be a custom name, and then the parameters. But for a constructor, we don't need an access specifier, we don't need a static, non-static, and we don't need a return type. And the name cannot be custom. So what is a constructor? A constructor is basically a function which doesn't return anything. That's why there's no return type. It's neither static nor non-static, and we don't need an access specifier for that. And it has the same name as that of the class. We cannot have a custom name for a constructor. So constructor is basically something which doesn't return anything and has the same name as that of the class. So in this case, our class name is fun. So this will be our constructor basically. This is a constructor over here. This is not a function, this is a constructor. How do we know this is a constructor? Because this has the same name as that of the class and it doesn't have a return type. If I add a return type over here, then, and if I change the name to something like fun1, then this becomes a function because the name is not the same as that of the class and it's a return type. And this will not work, by the way, if it's compulsory to have it the name of the constructor as the same name as that of the class. So this is a constructor over here, and these are its parameters. Now, in a constructor, you can do anything, like how you can perform anything in a function. So you can do anything in a constructor. So I can declare variables over here. Let's say I can do something like a is equal to 10. So I'm giving these these variables a value. I can give d a value, let's say 10.9, something like that. So this will basically work. So in a constructor, you can perform any function. You can do something like a is equal to a into a, or anything like that. Now, let me explain what this object has to do with a constructor. So when I create an object, so when I do fun obj1 is equal to new fun, this fun constructor is called. So now you understand what's actually happening over here. When I create an object obj1, a fun constructor is called. So when this fun constructor is called, it goes over here to this fun constructor and it performs everything, whatever this thing is. Let me remove this for now. And it performs all these functions. So it gives a the value 10 and b the value 10.9. It gives these instance variables some values. Now, when I call this hello method over here, the value, I'm calling it using the object obj1. So if I am using the variable a over here, what value will a have over here? The value of a will be the value of a we used when we called that particular constructor. So in this case, the value of a will be 10. Why? Because I called this with obj1, and when I declared obj1, I declared it using the constructor fun without any parameters. So the value of a and d is this. So whenever I call a method with obj1, the value of the instance variable will be that which is declared as a particular method or something. So let's see. Let's say this prints. Let me see what this prints. So I'll remove the static over here so that we can actually use the thing. I'll remove this over here, and this should print a. So now what value will a have? So this over here, the value of a should technically be 100, which it is. So let me give you a quick dry run again. The code directly first initializes these two variables. Let me remove the static also from here to make it much more clearer. So it declares these two non-static variables. Then it directly goes to main. It always goes to main first. An object obj1 is created, and when this object is being created, we make a function called fun. And when we call this fun constructor over here, which is compulsory when you're making an object, this constructor is called, and it gives these instance variables some values. And whatever other function, I mean, whatever other operations you want to perform over here, it does that. So it gives the value a 10 and it gives d the value 10.9. Now, obj1, so whenever I use object1, this obj1, the values of the instance variables will be these. Because when I made the object obj1, I called the constructor fun without any parameters. So when I call this function hello with obj1, and the compiler goes to this part of the code hello, the value of a and d will be this. So the value of a will be 10 and d will be 10.9. So over here, the value of a is 10. So this is what's basically happening. Now you will actually understand how important object-oriented programming is. Now let's say I create another object. Just a second. I create another object over here. Over here, I call this obj2, and I call obj2 over here. But now, if I call this obj2 over here, this method, again, obj2, when I'm declaring obj2, I call the constructor fun without any parameters. So the value of a will again be 10, and over here, when I call hello using obj2, the output will still be 100. So then what's the difference? Now what I can do over here is that I can make another constructor. So let's have a constructor in which I have some parameters. Let's say parameter I have int m and double, let's say I have n. Now what I can do over here is that I can give the value a as m and the value of d as n. And when I call this object, I give the value something like 13 and 14.8. Now, this might seem a bit complicated. Now, let me explain step by step what's happening. I made another constructor, fun, which has two different parameters. Now, keep a note over here is that what we are doing here is constructor overloading. Like how in function overloading, we have multiple functions of the same name but with different parameters, the order, type, and number of parameters. In same case, all the constructors have the same name, which is the name of the class. And we are differentiating between them based on the type of parameters. Now, when I call this, declare this fun obj2, it goes to new fun and this. So this is currently an integer value and this is a double value. Okay, so when I call this particular constructor fun, it finds a match for this particular constructor. So it finds which constructor over here. There can be multiple constructors, as many as you want, unlimited, and it finds those particular parameters. So when it finds the particular parameter order, the number and the type, it goes inside that parameter and it gives the value of a as m, which is 13, and gives the value of double d as 14.8. So now the instance variables, when I call obj2, have the values of 13 and 14.8. But in obj1, the values are 10 and 10.9. So now you can see how in the same program, we can have different values for the same variables. The variables are same, a and d, but we are dividing them into two parts, one obj1 and obj2, and then in each object, the values of these variables are different. And the constructor is being separated, how the compiler is choosing the constructor is based on the type of parameters, because it's constructor overloaded. So when I call this obj2 over here, it will, the value of a which will be used when I call hello with obj2 will be the value 13. So let's look at the output. So when hello is, so wait just a moment. So when I call this function, so I can select which function to call. We'll do main for now. So in the first case with hello, when I'm using with obj1, when the value of a is 10, the output is 100 because the square of 10 is 100. But when I'm calling it with obj2 and the value of a is 13, the output is 169 because 13 square is 169. So you can see how the same method, we can have different outputs for the same method with the help of objects. So now you can see yourself using this because it makes the code so much more compact. What I'll have to do now, if let's say I didn't have objects, I'll have to create 4 variables, int a, d, and then 2 more variables, another int, another double, and give them separate values. But in this case, we're using the same variables. So instead of having many variables and getting confused, we can just use two variables and just make different objects with different values. So this is basically what constructors and objects are. This will take a bit of time to grasp because this is a heavy topic. It's a very big topic, and this is what Java is completely based on. But when you're actually writing proper codes, you'll actually keep on learning. So I would say go experiment this, play around with objects, try different parameters, write codes of your own. Any basic code you have, try to write it again using object-oriented programming. So, as I said, this constructor is constructor overloading and it differentiates based on the parameters. Now, let's say these parameters, now this is kind of like a different topic, kind of, it's similar, but you want to use this or not, it's your wish. Let's say if I want to use even lesser variables, because I'm using two extra variables, m and n over here. So let's say if I do something like this. What if the parameter variable is the same as that of the instance variable? So if the name of the instance variable, which is this, is the same as that of the parameter variable, and I do something like this, will this work or not? So think about it for a moment. Will this work or not? Because the name of the instance variable is the same as that of the parameter variable. And if you thought that this will work, you're wrong because it won't work. What does A is equal to A mean? Which A is this? Which A is this? It doesn't really make sense. It confuses the compiler. And as someone who's reading the program, it confuses me also. What D is this? Am I giving this D this value? Or am I giving this D this value? It's very confusing. So whenever the instance variable name is the same as that of the parameter variable, the compiler hides the instance variables. So what does this mean by hiding the instance variables? So when I'm calling these, using these variables over here, this is A and B is referring to only these variables. It forgets about this particular variable. So how can we solve to get this particular variable? We use the keyword this. So we can do something like this dot A is equal to A and this dot B is equal to D. Let me explain what's happening over here. Let's say I didn't have this, right? So then this A and this D is referring to only this A and this D. Because why? Because the name of the instance variable is the same as that of the parameter variable. So the compiler hides the instance variables. So it forgets about these variables as if these never existed. And this A and B is only referring to the parameter variable. Now to access the instance variable, we have to use a keyword called this. So if I do this dot A, it's referring to the instance variable. And if there's no this with the variable, then it's referring to the parameter variable. So what this is doing over here is this code. This dot A means this instant variable, the value of this instance variable is equal to this parameter variable. So the value becomes 13 and this becomes D. So again, the output will be the same. So again, 100, 169. But what we are doing over here is that we're using two less variables. So this is this variable, this keyword, my bad. This keyword you use only if the name of the instance variable is the same as that of the parameter variable. So this is helpful if you don't want to overcomplicate yourself with so many variables if you're writing massive codes. So this is a very helpful tip, this keyword, which is used to access the instance variables. So that was basically the basics of object-oriented programming. There's a lot more to cover in object-oriented programming, how you're passing objects as parameters, and there's so much more to cover in objects, which I'll be covering in future videos. But for now, I would say you go experiment with these objects, constructors, this variable, different types of functions, static variables, non-static variables. There's a lot to learn in this. So have fun with it, enjoy, and play around with all this so that you get a better hang of this. So that's it for today, everyone. Thanks for watching. And if you have any queries or suggestions, you can mail me. My email will be in the description down below. And thanks again for watching.